Hello, everyone. Today we have a lab about BGP exploration and attack lab, and that's a final project for Red Deer Polytech and Sterling College. So first of all, what is BGP? BGP or Border Gateway Protocol is a standardized exterior gateway protocol designed to exchange routing and reachability information among autonomous systems on the internet. So before we start the lab, we're just gonna talk about the lab setup. This lab will be performed inside a seed internet emulator. So to download the emulator files, all the lab setup files are available in the seed lab website, which is in this URL. That's the website. And to download this BGP project, the link is as follow. So you just go to the website and go to lab setup and go to Ubuntu 20.04, 20.04. You click on it, and you have different type of labs. You go to network security, you scroll down, and then you find the lab that we're gonna work about. You just click on it, and you can find the setup lab setup zip file. But you can just download it and unzip it in your environment. So to start the emulation for this lab, uh, we started by running the following Docker commands using the terminal from the output folder to build and start the containers. So first, we just go to our lab setup, outputs, and here we have all the folder for the containers. Just come here and open a terminal. And we need to do this command, Docker compose build, to build all the containers. And to start the Docker, we just do Docker compose apt or DC apt. So just to save some time, I already did this step, and it's right here. So just write DC apt, and all the containers are working and running. For the network map, all the labs will do it. Each computer, host, and routers running inside the emulator is a Docker container. So after the emulator starts, the map can be accessed from this URL. If you click on it. So this is the map of all the routers and hosts that we're going to work with during this project. BGP exploration. In this section, we explore different terms and components involved in the BGP protocol. First of all, we'll talk about autonomous system. An autonomous system is a collection of connected internet protocol routing prefixes under the control of one or more network operators on behalf of a single administrative entity or domain. So in this task, we focus on STAB autonomous systems. We will see how it pairs with others. For this type of autonomous system, we will gain like a glimpse of how BGP works. So the first task, it's under understanding AS155 BGP configuration. So from the BGP configuration file, we will identify who AS155 pairs with. We will study its BGP configuration to complete this task. And we can do the following command to access the configuration file. So let's demonstrate this. So go to the search bar and just type 155. And we see that the autonomous system 155 is here. So we go just to the router. We launch its console. And we do the command that we just saw. So cat C bird. So this is the configuration of this router. So you can see either from here, like the BGP sessions, which autonomous system the 155 is pairing with. We see that's autonomous system 2, 4, and 156. They have BGP uh, connection. And you can see it in the configuration file as well. We can see here that protocol BGP with AS2 is established on the local IP address, which is 10.102.0.155, and it's the same IP address here. So you can see it either in the terminal or in the website. Second one is autonomous system 4. So 2, 4, and autonomous system 156. So that's the three autonomous system that the 155 is pairing with. So for the next task, next task, we will see like AS155 pairs with several autonomous systems. So if autonomous system 155 loses the connection with one of them, it can still connect to the internet. So we'll design an experiment to demonstrate this by enabling or disabling BGP sessions, either from the graph or from the router terminal as well, like as shown below here. So you see that we show the protocols. We have like BGP sessions app. We just like disable peering with AS2 and see if we still can have like access to internet. So we go to the same router. Okay, we show protocols. So we see here that we have connection with autonomous system A2, which is app, and with autonomous system for app as well. So we will try to first ping like any other, try to have. So we're gonna open console for 155 host, and we'll try to ping, for example, 180 host, or maybe 160. So we just ping 10.160.0.71. We see that there is connection. We just go to the filter and try to see. Okay. So we see here that we have connection between 155 hosts and 160. So now we're gonna try to go to the host and disable like any connection. Let's disable just from here. We see that the connection, the path is changed. So now it's using the autonomous system 2 peering to go to reach the internet. So as soon as I will enable again the AS2, the connection path will change. So let's do that. So we see that the connection change here. Let's disable AS4. So nothing changed because it's using AS2 in the first time. So that's how like we demonstrate that even like if we disable like autonomous system 2, it will still reach internet or its destination through AS4. So that's for this. That's for this task. Sorry. For task 3, the objective of this task is to understand the BGP updates. Uh, we will run TCP dump on AS150 BGP router and use it to monitor the BGP traffic. So our job in this task is to do something on AS155 BGP router to trigger at least one BGP route withdrawal and one BGP route advertisement messages. So these update messages should be captured by the TCP dump command on AS150. This is the command for TCP dump. It's gonna be from 150. So we're gonna use the interface IX100 to capture any TCP messages that have a destination port of 179 that the BGP use. So let's go and do that. So we go to 150. Here's 150, which is this one. Install the console. Okay. And then we will run the command. So we see that the interface of the BGP is IX100. So that's the interface that is facing the outside internet side. So let's paste. Click enter. Now the TCP dump is working. I'm just waiting for update messages, and we see that it starts intercepting like receiving like BGP update messages. So let's go to 155 now and do something in it. So what I'm gonna do is just I will disconnect the AS155 and see it, if 150 will receive any notification about that. So let's go ahead and disconnect it. We see that we have like a message of withdrawn routing. That's an update message. That's the 150 router received about the 155. So I'm gonna just reconnect again and see if we will have a new update message. Let's just refresh it. Okay, I'm gonna reconnect. Just wait a little bit. And we see here that now it receives another BGP update message saying that the autonomous system 155 is now like alive and it can be used to like reach the AS155. That's the update route of 10.155. That's the updated information, update message, and all the information about. So that's about this task. The next task is about configuring AS180. So this task, AS180 does not pair with anybody. So we need to complete the configuration of AS180 and AS175 BGP router, so they can directly reach each other. So in this task, we configure like both AS180 and AS171 routers, so their hosts can reach each other. And these are the commands. Let's follow here. That's for AS180. And the command is a bit longer, so I just shorten it here. And that's the command for AS175. So now we will go and do the configuration so they can reach each other. So we go first, we look for autonomous system 180, which is here. So if I come here, I can see that this is autonomous system 180. It have no BGP peers. And the autonomous system 171, it have like a BGP session, but only with AS11. So we're gonna check first if there is like connection between the two autonomous system. We go to host in 180, and we'll try to ping the other host in the autonomous system 171, which is 10.171 uh, 171.0.71. So 10.171.0.0. So we see that here there is no connection between them because the destination network is unreachable. So we proceed with the configuration to make them connected to each other. So we go first to the router 180. We're gonna take the Docker container ID. Okay. And then I will go here. Let's just okay. I will open a terminal here in the BGP exploration file. So the command is docker copy. We will copy the bird configuration for the autonomous system 180. And we'll copy it to the BGP file so we can edit it. So let's call it BGP bird 180. Okay. So we see that we have the file here. We just go inside. That's the file, same file. So we jump, let me go to the bird configs. And that's the configuration for 180 and 171. So for AS180, we're gonna take all this code, gonna copy it and paste it in the 180 configuration. So it just go after the interface network 0. So we just paste all everything here. Okay. So this one basically just like configure the autonomous system 180 router to use the BGP protocol. And it will use like the local community, so it can spread the BGP update message to all the autonomous systems. And then we configure like a BGP peering with AS171, which will be on the local interface of 180 is 10.105.0.180, and on the autonomous system 171 is 10.105.0.171. So we're just gonna copy back to the Docker container. So I'm just gonna change this one. Okay. We're gonna do the opposite. We're gonna copy it from our file to the router container. Okay, it's done. So now we're gonna go to the router 180 and see if the configuration is right. So we see here that we have the configuration that we just faced about the autonomous system 171. So the next command is to commit this configuration. We're doing like BGP configure. It's in progress. Just do it again. So the configuration file is configured. Now I'm gonna go to the autonomous system 171 and do the same as the router. Just copy the Docker container and do the same thing. I'm just gonna use the container ID. Okay, and then change it to 171. Actually, I need to change. Okay, 71 and the Docker container ID. There we go. Now if we go back to our file, which is here, we will find the bird for 171 here. So for this one, it's the BGP is already enabled because it has a peering with autonomous system 11. We're just gonna add like another peering with autonomous system 180. So that's the file. Just find, sorry. So that's the configuration for the autonomous system 171. We're gonna just copy paste this command to enable peering between the two autonomous systems. Okay. I'm just gonna paste it right after the autonomous system 11. Right here. Okay. Save. And do the same again on the opposite way. So we're gonna copy now from our file to the router configuration file. So it's done. Let's go check again. That's the autonomous system 171. So yes. So that's the file. Let's check. Yep. So we see the autonomous system 11 here, and also the autonomous system 180. That's the configuration that we did. We're just gonna commit the configuration as well. So configured. It's reconfigured. So now we're gonna go back and check if there is connectivity between the two autonomous systems. We go to the host on 180. We see that destination was unreachable. Let's do it again. And now we see that there is connection between the two autonomous systems. And that was for this part, this task. So next task will be about experimenting with BGP and IGP, which is OSPF in this case. So for this task, we first need to find some traffic that goes through AS3, and then we will ping IP address 10.164.0.71. We will disable the IBGP and IGP session on AS3 BGP router from the command line and as shown below here. So let's go and find first the autonomous system tree. Autonomous system tree. So we see that this is the autonomous system tree, which have like 4 router, as we see here. And then we need to find, we need to ping 10.164.0.1.7.71, sorry. So I have some before like configuration file here, BGP commands. So that's for the IBGP here. So I'm gonna go to host in 151 and ping that container. So 151. So let's go in this host and ping this IP address 164. Okay. Let's check if it's the same. 164.0.71. Okay. So we see here that there is a connection that's using the AS3. If we click here, let's see the AS3. Yeah, okay. So let's change. We're gonna change the router. Let's see if we can use one of those. 64. وهذه نعودها من هنا task 5. Okay, now we will go and try to find AS3 and ping this IP address. So here we will find AS3, which is here. This is the autonomous system. And we'll try to ping that IP address and see if we can find the traffic that goes through the AS3. So first of all, let's go and, for example, go to the host 160. Let's go to 160 and try to ping that IP address. So we see that there is connection that goes through AS3, which is this one, to the destination IP address. Okay. So now what's the task is to disable IBGP and IGP OSPF and see what will work. So that's the AS3. So the console. Okay, now we're going to show the protocols. So these are the protocols here. We have the OSPF1 protocol, that's for IGP, which is running. And then the IBGP sessions that are established as well. So what we're going to do first, we're going to try to disable either IBGP 1, 2, or 3 and see uh, what will happen to the connection here. So disable. Let's try IBGP 1 first. Okay, and then IBGP 2. And then if we do like IBGP, I think it's using IBGP 3, right? So we're just gonna disable this and see. So we see here now that's the connection is reachable because the IBGP uh, protocol, IBGP 3 is disabled. So like that's will happen. Like the router will receive the ping, but it won't be able to forward it because its IBGP session is disabled. Let's just enable it again. Let's give it just a little bit. There we go. Now we see that the connection is established again. So we'll do the same with the OSPF one. Let me just enable both IBGP 1 and 2. Okay, so I will disable OSPF 1, which is an IBGP. Okay, so we see here that there is connection like between the two routers, but from it's in the same autonomous system. We see that now there is like connection, IBGP connection, like BGP connection between this router and this router in the same autonomous system is connected, but the OSPF inside the autonomous system between the four routers is disabled, so the connection won't be like forwarded through this autonomous system to reach its destination. So let's just enable it again. So for this one, I need to go to Finken host, stop it, and start again. Now we see that there is connection between the two uh, from the start to the destination. So like for if we disable the BGP connection, so it won't be like connection even between the autonomous system 160 and autonomous system 3. So even this connection won't be able to be reachable. But for OSPF, we saw that there is connection between autonomous system 160 and autonomous system 3. But inside the autonomous system 3, there is no connection because the OSPF was disabled. So that was for this task. So for next task, it's about IP anycast. So IP anycast is a network addressing and routing methodology in which a single IP address is shared by multiple machines, usually in different locations. So when we send a packet to this IP address, one of the computers will get the packet. Exactly which one we get, it's hard to tell because it depends on the routing. Like sometimes there is like no connection between two autonomous systems. That's how, as we saw, like between autonomous system 180 and 171. So in this case, like the packet will like take another path to reach like whichever like closer and reachable IP address. So IP anycast is not naturally supported by BGP. So one of the well-known application of IP anycast is DNS. So we know that DNS when you send like a DNS query. So like any DNS server that is close to your destination or reachable will receive your packet and answer it. So on the emulator map, we type 190. in the search box, we found out that AS190 has two networks. So let's see that. As we see here, like 190, it has like two networks. One is here and one is here. So if we see like this host here, so if we see that this host in this part has the IP address of 10.190.0.100. If we click on the other host in the other side, it has the same IP address. So if we ping this address, it depends on the topology of this network. Like if we ping from different autonomous systems, we will reach either this destination or this destination. It depends. So one network is connected to IX100 and the other is connected to the IX105. So if you see here, this is IX100. This is connected to the Internet Exchanger 100, and this one connected to Network Exchanger 105. A closer look to these two networks will reveal that these two networks have the identical network prefix 10.190.0.0/24, which I just showed you. The only hosts on these two networks have the identical IP address 10.190.0.100. So we set the filter on the map to ICMP to visualize the packet trace, then look at the BGP routers on the path. This is the different path as shown in the screenshot below here. So we ping from this IP address, we ping from this host to that IP address. We see that the path goes in this way. And the other picture, that's a different path that goes to the other destination. So we'll just demonstrate that. So so I have the filter to ICMP to check the packets. Let's see. I will try, for example, to go to 161 host and try to ping the IP address of 190.0.100. Okay. The 100. Okay, we see that from this host, when we ping this IP address, we reach this destination. So this is either be like the closest, or maybe there is no connection to the other location. So we stop this and try another path. Let's choose the host on 152. We ping the same IP address. Normally we have here and here. So 190. That's 100. Okay, it's the same IP address. Okay. Let's try to find out another system. Let's go to this 151. Now we see that this packet doesn't go to this destination here, but I choose this destination. So as I said again, maybe it's the closest route to this IP address, or there is no connection between peering autonomous system that make this path reachable to this one. So that's how IP anycast. So you just ping the same IP address, and it will reach either this destination or this destination, and then you will get your reply. So that's for this task for IP anycast. Now we reached the main topic of this final project, which is BGP prefix attack. Like BGP route hijacking, also called prefix hijacking, is a typical attack on BGP. In this attack, the attacker's BGP routers announce the IP prefix that are not assigned to them. So the traffic to this IP prefix can get rerouted to the attackers, who can intercept or modify the traffic. So many of the incidents on the internet are caused by such an attack, although they are mostly caused by the misconfigured BGP routers. And we can remember like what happened to the YouTube, which wasn't reachable during like a couple hours due to a misconfiguration on a Pakistan router company. So that's typically what we're gonna demonstrate here, what happened and how we're gonna uh, gain back the prefix ownership, and then how to prevent this from happening again. So first of all, we're gonna do launching the prefix hijacking attack from AS161. In this task, we will launch the prefix hijacking attack using a BGP router in AS161. So let's go inside AS161. Sorry. So this is the router for AS161, which has an IP address of 10.161 and then 10.103. Okay. Our goal is to hijack the IP prefix owned by AS154. If the attack is successful, all the packets going to AS154 will be rerouted to AS161, where they will be dropped. Essentially, we are black hole in AS154. So this is the command to black hole the AS154. We're gonna use a static route, and we're gonna like we will update a message that's from the AS161 that it owns the IP address prefix of 154 by using a prefix length of 25, because the AS154 have the prefix length of 24. We will use the prefix length 25, and we know that a router that have like two uh, destination to the like two route to the same destination, it will use the highest prefix length. So that's how it works. So let's go to 161. First of all, let's check one autonomous system 154, which is here. We're gonna try to ping, for example, from host 152. We're gonna ping a host in 154, which I did before. So we see here like 10.154.0.71. We see that the ping is successful here. It goes to the desired destination. Let's configure now autonomous system 161 to receive the packets of this autonomous system. First of all, we go to the console and we do the same thing. Let's see. I'm gonna take the container ID. Change here to 161. Okay. Okay. Now if you go to the file is here. So what we're gonna do first is let me okay. So that's the bird 161. I'm gonna go to the end of its configuration and add that prefix hijacking command. So this is the hijacking command as I just showed you. We're gonna announce the prefix 154/25 to be our, like any packet that's sent to this network address for this in these two subnets will be redirected to the AS161. I'm just gonna copy and paste it in the end. Okay, save. And then we're gonna copy paste container here. So we're gonna copy back the configuration to the container. Okay, so it's done. Let's go back to 161 router. So we see the protocol hijack configuration that we did. So I just need to uh, commit the configuration. So before I commit the configuration, let's go one more time to 102 and check the ping. So for now, we have the ping that goes from 152 to 154, which is like normal. Now I'm gonna commit this configuration for 161. So we see that it's reconfigured. So now if I ping, it should be hijacked. So it's the same IP address, 154. So now what happened? We see that the packet doesn't go to 154, right? Instead, it goes to the router of 161, 161 here, where the packet will be dropped or like received. Let's see. We see here like there is no connection. We're pinging, but there is no connection. So that's what happens. A simulation to what happened to YouTube network. Just stop that. So that was for hijacking, prefix hijack. So the next task is like normally this is the AS161, sorry. And 161 has only one BGP session with AS3. And AS3 is its internet service provider. So normally we will go to this ASP and just like prohibit AS161 from sending any hijack network. So before that, let's try to fix the problem from AS154 to gain back its network ownership. That's for the next task, fighting back from AS154. So the loss of the service is very significant, as you know. So the operators of AS54 decide to fight back. They want to steal or gain back their own network prefix without the help of AS3, which is the ISP for the uh, AS161. So we will reconfigure the BGP routers on AS154 to get the traffic back. This is the command here. So we see, as I explained before, the AS161 has the prefix length of 25. So now we're gonna reconfigure AS154 with the prefix length of 26, which will be the highest prefix length. Then any router that will send traffic, it will send it to this router because it has the longest prefix length. Then we like choose all the subnet networks. So all the traffic will go back to this autonomous system 154. So let's go and search for, this is the router for 154. Let's search the console. Same steps, gonna copy paste container. I come here. Let's change it to 54. Is the container ID. Okay, back here. So we're gonna find, this is the bird for 154. So we will do the same thing. We just go to the end of the configuration file. And attach this configuration, which will gain back the network ownership with the prefix of 26. I'm just gonna copy and just paste it in the end. Okay. Now we go back again. I think we have volume here. Oh, I copied it. Yeah. So let me go back and just copy. Copy the file, which is bird 154. Okay, so now we go back to the autonomous system 154 and see if the file is recovered. We have oh, it's etc, not etc. See, there we go. So that's the configuration of the autonomous system 154 router, and that's the configuration that we just had with the prefix of 26. Okay, so I do the same. I will commit the configuration, but before again, let's check the pinging. So we see that the ping goes to the autonomous system 161 again. So let's commit the configuration here. Now we see that autonomous system 154, sorry, gain back its network prefix. So that's for the that's for this task. But like we know now that autonomous system 154 gained back its network prefix, but the autonomous system 161 still can hijack any other network in the internet. So to prevent this, we need to configure like the ISP of the autonomous system 161, so it will prevent any prefix hijacking from this autonomous system. So let's go first and okay. So now I will go to the autonomous system 3. That's 1.6 autonomous system. Let's go to autonomous system sorry, choose this one. So this is the autonomous system tree. That's the ISP provider for 1.6. So we're gonna go to this router and do some insert a filter. So no more BGP hijacking will be sent from AS161. I'm just gonna open the router. Same steps again. Copy the file, container ID. Okay. We paste it to, let's call it bird AS3. Okay. Now we'll go back. This is the file. So here, all we need to do is go to the ISP and look for the BGP peering with AS161, which is here. And I'm just gonna add a filter just right here. And the filter is as follow. This is the filter. So this is the command. So this command just so like if any network that is like uh, advertising from AS161 that is not part of the network address, which is 10.161.0.0/24. If any network not matching this address, then the ISP will reject this connection. So we prevent any BGP hijacking from this AS. So I'm just gonna copy this, just this command here. We paste it here. Okay. Then we go back to the AS, the same command. So if you go scroll, if we look for, this is the AS161. Okay. Maybe it didn't. Okay, okay. I did a mistake. So I need to copy paste back. So let me just, I just copied from the container to my file. So I'm gonna do it backward. Okay, now I'm gonna copy from my file to the container router. There you go. We do the same command now. We need to see the configuration, which is right here. So if any network not matching this IP address of 161, it will be rejected. Okay. So first of all, I'm gonna go to the AS154. AS154 here. Just gonna take out this configuration for fighting back. And we will see if it will work without the configuring the router on 154. Okay, so that's configured. We're gonna copy the file to the router. There you go. Let's check our configuration. So we see here that we have no configuration here in the router 154. Let's just commit the configuration. Okay, it's reconfigured. So now we'll check again the thinking and see. So we see now that the prefix network is hijacked, doesn't go to the network 154, it goes to the network 161. Now we're gonna commit the configuration on the ISP and see if it will block its hijacking uh, advertisement. So that's the AS3. Okay. And we see here that we have that. Just a second. Okay. We see that we have this command here to prohibit. So I'm just gonna commit the configuration. So let's check. Now we see that the traffic went back to the owner of the network, which is 154. So now from the ASP, that any BGP hijack is blocked on the ISP. So that's how we fix this problem. And that's the end of this project. So that's the task 9 that I just did. We fixed the problem from AS3. We just use this command to reject any connection, any advertisement that is not matching this IP address.